Imagine dropping, I don't know, $50 million on this massive state-of-the-art software modernization program.
Oh, a massive investment.
Right. And then you walk onto the engineering floor and realize your best developers have completely abandoned it.
Yeah, they just bypass the shiny new tools entirely.
Exactly. Instead, they're keeping your company's critical infrastructure running
Yeah.
using like a chaotic web of personal text files and frantic Slack messages.
It is a profound disconnect. I mean, the vendor check's clear, the implementation is technically done, but the day-to-day reality for the engineers just grinds to a halt.
Which is exactly why we are tackling this today. Welcome to the Deep Dive.
Glad to be here.
We are exploring a genuinely eye-opening article published recently on March 16, 2026. It's by Suyash at CodeVigor, and it was featured on the Code blog.
It's a fantastic piece.
It really is. The focus is on why massive, expensive software modernization programs secretly fail, and why the tools designed to fix them usually just miss the mark.
And if you're listening to this, you really should care about this dynamic because it affects you directly.
Oh, absolutely. Whether you're a tech leader trying to understand why your team is moving so slowly, or, a developer frustrated by clunky tools.
Or even just someone who loves knowing why big, expensive systems break down. This deep dive is going to give you a massive aha moment.
Because it's about the stark gap between management and execution. So, okay, let's unpack this.
Let's do it.
Where does this breakdown actually start? Because, nobody sets out to build a tool that engineers hate.
No, of course not. But it really starts with diagnosing the right disease. When these 8-figure tech projects fail, leadership almost instinctively points the finger at scope creep.
Right, or they blame technical complexity.
Exactly. They say, oh, the legacy codebase was simply too tangled. But the source material identifies a much more insidious, silent killer.
Developer friction.
Yes. Developer friction. It's not just about writing code. It's about human behavior, cognitive load, and organizational misalignment.
It's one of those terms that gets thrown around, but it rarely gets treated like the systemic threat it actually is.
Because it's really hard to quantify from the outside. For a developer, friction is the cognitive overload of spending, like 70% of your day just searching for context.
Just trying to figure out what's going on.
Right. You're sitting there staring at a sprawling microservice architecture, and you hesitate to deprecate a single API endpoint because the live behavior of the system is a total black box.
So you end up relying on tribal knowledge.
Always. You're constantly interrupting the subject matter experts.
Yeah.
Pinging that one senior engineer who has been there for 10 years to ask how a specific module routes data.
And the terrifying part of this invisible decline is that it doesn't even show up on executive dashboards.
That's the critical detail from the source. It is a massive blind spot.
Yeah, because commits are still happening. Code is being checked in. But underneath, the velocity just drops off a cliff and error rates rise.
And then the teams overcompensate with heavier processes. More reviews, more testing.
To me, this is like trying to remodel a house in the dark while looking at a blueprint from 1990.
Oh, that is a perfect analogy.
Right. Sure, you're swinging the hammer, so it looks like work is getting done. But every swing is terrifying because you don't know what's behind the wall.
You have no idea if you're hitting a water pipe or a load-bearing stud.
Exactly. Which inevitably leads to this highly defensive coding and severe disengagement from the team.
Because you're forcing highly logical people to work in an inherently irrational environment.
But this brings us to a really uncomfortable question. If everyone knows modernization is hard, why do the expensive tools designed to help actually make it worse?
Well, it comes down to a structural tension outlined in the text. It's what you could call the top-down trap.
The top-down trap. Tell me more about that.
So think about how these tools are built and sold. They are usually built from the top down. Executives want abstractions, summaries, and risk indicators.
But don't executives absolutely need those high-level dashboards for governance and budget approval? You can't have a VP digging into code logs.
What's fascinating here is that you're entirely right. Leadership absolutely requires that abstracted view.
Right, they have to steer the ship.
Exactly. But the fatal flaw is when a platform optimizes exclusively for that executive view. Developers need precision, immediacy, and behavioral.
So when you only serve the executive layer, you create this sort of parallel system of understanding.
Precisely. The dashboards say everything is fine, the migration is on track. But down in the trenches, the developers know that their understanding is incredibly fragile and manual.
And then trust just breaks down completely.
It evaporates.
So the platform is speaking a foreign language to the people actually doing the work. And our source breaks this down into an unholy trinity of bad tools. Let's look at those.
Yes, the 3 specific ways platforms fail developers. Number 1 is their reliance on static artifacts.
Like architecture diagrams.
Right. Tools that focus heavily on structure rather than how the system behaves live. A diagram is fine for your first day, but it's fundamentally insufficient for making a complex engineering decision.
Because it doesn't tell you anything about the live traffic or the actual behavior under stress.
Exactly. Code is an active breathing system, not a static building, which leads to the second failure, tool sprawl.
Tool sprawl. Forcing developers to context switch constantly.
It's a nightmare. Because those diagrams are lifeless, developers have to stitch together reality using a dozen different apps. Code analysis in one tab, observability in another, documentation somewhere else.
It's brutal cognitive load. You're holding fragments of system state in your head while navigating 5 different user interfaces.
Just to answer one basic question, if I change this, what breaks?
And then by the time you find the answer, you're exhausted. Which brings us to the third structural failure, right?
Yeah.
One-phase optimization.
Yes. Tools that are only good for the initial migration.
Right. They help you move to the cloud over the weekend, but then what?
Then they become useless overhead. They're purpose-built for the heavy lift, but they offer nothing for ongoing day-to-day operations.
Which highlights the ultimate irony from the text. Organizations spend literally millions on these platforms, but the developers just bypass them.
They ignore them entirely. They go right back to informal conversations and hoarding personal notes.
It's wild. Okay, so we've diagnosed the problem. Now let's pivot. What does this all mean for the people doing the actual work?
We have to redefine what developers actually need, and the article lays out 3 non-negotiable pillars: context, confidence, and speed.
Context, confidence, and speed. Okay, let's break those down. What does context really mean here?
Context must be close to the code. It has to show how logic executes and data flows right where the developer is working, not buried in some external dusty doc.
So it's about seeing the why behind the code without breaking your flow state.
Exactly. And the second pillar is confidence.
Knowing you're not going to break production.
Right. Confidence means knowing the exact downstream effects and edge cases before you deploy a change. When you have that, you stop coding defensively.
And then there's speed. And I want to jump in here because the source makes this really profound point about speed.
It completely reframes it.
Yes. Speed isn't an input, it's the outcome.
Yes, you don't just tell people to code faster.
Right. If you give developers context and confidence, speed just happens naturally. They spend less time investigating and less time doing rework.
You remove the friction, and velocity naturally increases.
So how do we actually do this? How do we fix this at a systemic level?
Well, the text introduces a game-changing concept called system intelligence.
System intelligence. Okay, break that down for me.
It fundamentally changes the game by moving system understanding from being a manual piece-together task to a built-in capability.
Here's where it gets really interesting. Because the concept of persistence comes into play, right?
Exactly. Persistence is huge.
Yeah, because usually when a senior developer leaves, all that context walks out the door with them, and the new person has to reconstruct it from scratch.
It takes months. But with system intelligence, developers inherit the context. The understanding lives in the platform, not just in human memory.
So day one, a new hire can query the system and actually understand the live behavior.
Yes, and this creates a massive compounding effect.
A compounding effect, like ripples out.
Exactly. Developer experience becomes an operational lever, not just some soft HR metric.
Because faster developers reduce the bottleneck on your subject matter experts.
Right. The senior engineers aren't being interrupted constantly, so they can actually do high-level architectural work.
And it goes beyond just the engineers, right? Compliance teams get clearer explanations.
Oh, absolutely. Audits are suddenly much less painful, and disagreements entirely change.
Think about your own workplace for a second. How many times are decisions totally stalled because 2 different departments are looking at 2 entirely different sets of data?
It happens all the time. People argue based on opinions and intuition.
But system intelligence provides shared visibility. It solves this.
Disagreements move from opinion-based to evidence-based because everyone is finally looking at a shared, validated view of the system.
Which brings us to the ultimate test of any of these tools.
The core thesis of the Codora piece.
Right. The ultimate test of any modernization platform is simply adoption.
Yes. If it doesn't reduce friction in the daily workflow, its value is purely theoretical.
It's just a shiny toy.
Exactly. And that massive tech upgrade will quietly fail no matter how good the executive dashboards look.
Wow, we have covered so much ground today, from developer friction to system intelligence. Thank you so much for joining us on this deep dive.
It's been a great conversation.
But before we go, I want to leave you with a final lingering thought to chew on.
Let's hear it.
We talked about how tribal knowledge and personal notes are the fallback when million-dollar tools fail. So ask yourself, how much of your own company's critical infrastructure is currently relying on the fragile memory of just one or two quiet employees who might leave tomorrow?
A truly terrifying thought for any tech leader.
It really is.
Yeah.
Keep questioning the systems around you, and we'll catch you on the next deep dive.